Hi, everybody. Ooh, I see I'm catching some light here with the window. I'm going to try to slide over a little bit. Hope you can still hear me okay. Let me know if otherwise. I try to get some of that light out of the view here. We're going to get started. It's about 1 o'clock, and this is our first webinar of 2026. So thank you for being here. We really appreciate you guys spending time with us. And we are here for all your testing needs, and we'll have a little Q&A at the end. So I'll give you my little spiel. If you've been here before, you've kind of heard it. My name is Jenny Novak, and I'm the marketing manager here at Dunn Fire Protection Labs. I help coordinate the webinars, so things that you need before and after, feel free to reach out. Welcome back if you've joined us in the past, and thank you for joining us if it's your first time. We have a good record registration today, so we're excited about that. Nice to see the interest out there. A quick intro about us. We're an independent testing laboratory. We've been doing testing firefighting foam for over 25 years. We also test antifreeze, dry chemical agents, and sprinklers, which we'll be talking to you about today. In 2024, we were acquired by NFPA Global Solutions, and we've continued to provide the same fast, reliable, and quality test results that you guys have all come back again for. We're always asked if we're certified or accredited. Dunn is ISO 9001 certified, and we also have our 17025 accreditation by A2LA for automatic field sprinkler testing. So just a little housekeeping before we get started. If you do have any questions during the webinar, feel free to type them into that Q&A window. We'll save them up till the end, and we'll have a nice Q&A session all at the end. You can get to it by clicking the 3 dots. So if you haven't been able to get to that, you can give that a look there. If you want to stay till the end of the webinar, people ask a lot. One of the most popular questions I get is, will there be your certificate? Are there any credits for these webinars? We have partnered with NICET. We're a NICET partner in training. So a lot of people do use our webinars, especially the sprinkler one, I think, for credits like NICET. I do need a little time to get those certificates out to you. We have quite a few people on the line, so I'm hoping to get those out within the next couple days here for sure, hopefully by the end of the week. And you can expect those in your email box. There'll be a PDF attached of your certificate, so give a look for that. And we also send out separately an email with the recording link. So we are recording the webinar. You can share it with people that weren't able to go on the live, rewatch it. We also post it to our YouTube channel. In that email, we also have a survey, ask for your feedback. Let us know any topics you'd like us to cover. Give us any feedback there. So I think I'm going to turn it over now for our speaker today. You all have been here before for Grant, but we're lucky to have Alyssa, and she's going to be doing the NFPA 25 sprinkler testing. She was previously the lab manager, but she's the general manager here at Dunn. She has extensive knowledge of the firefighting foam, sprinkler, dry chemical, agent testing, and antifreeze, as well as NFPA 25 requirements. So now I'd like to turn it over to Alyssa to talk to us about sprinkler testing.
Thank you, Jenny, for the introduction. We'll go ahead and get started here. As Jenny mentioned, I'm currently the general manager here at Dunn Fire Protection Lab. I've been with Dunn about 7.5 years, previously the lab manager. Originally started as a lab technician, so I've worn a few different hats in my years here at Dunn. Just a quick disclaimer here for this presentation. Any opinion expressed in this presentation is the opinion of the author and does not necessarily represent the official position of NFPA or its technical community. I see lots of requests for certificates in the comment section. No need to request them. Jenny will send them out if you are registered and attending. All right, we'll jump right into the field service. We're going to really be focusing on the NFPA 25 section 5.3 of the standard. This is where the testing requirements come from. So sample sprinklers shall be submitted to an approved testing laboratory for field service testing, and that's according to 5311. What is an approved testing laboratory? There's no direct or defined definition of what an approved testing laboratory is, but the annex, the A5311, does provide an example. So ISO 17025 is a standard that laboratories can be accredited to, and that provides general requirements for the competence of testing operational laboratories. So Dunn is ISO 17025 1705 accredited, so that would be an testing laboratory for sprinkler testing. Looking at this postcard here on the right-hand side, this gives a good overview of the sprinkler testing intervals. So section 5.3 says you need to submit your samples to a testing laboratory. This postcard here is a summary of the standard requirements for when to submit your samples for testing. So all of the references within this presentation are going to be the 2026 edition of NFPA 25. That is the most current edition. If you're referencing a past edition, these requirements may differ slightly. But for the purposes of this webinar, it is the 2026 edition. If you're familiar with the 2023 edition, these requirements didn't change, so it is something that stayed the same.
Well, she's saying our volume's pretty low, so I'm wondering if we could see if yours turns on. We're gonna get feedback on our side.
You could mute yourself and then I could unmute.
Give that a go.
Can you hear me better? Is that, are we still getting feedback?
Try it again.
All right, can you hear me now?
Sorry, guys, we're in a new conference room, so we're just getting used to the audio. I think we're gonna go back to the way it was.
Is that better or still quiet? Better?
Okay, yeah, maybe just, talk a little
I'll
louder.
just talk a little bit louder.
Perfect, thanks, Alyssa.
Alrighty. So yeah, when to send your sprinklers in for testing, you're gonna be looking at this postcard here is a good summary. So if your sprinklers fall into different categories, you're always gonna follow them the tighter requirement. So if you have a harsh environment sprinkler, that is going to be the 5-year testing interval. That's the shortest interval requirement. If you have a sprinkler that is listed as corrosion resistant, the initial testing would be at 10 years, and then the subsequent testing is every 5 years after that. What is a harsh environment? There's no specific definition in NFPA 25, but the annex does provide some examples. So this would be like paper mills, the areas like outside, or if you have areas that are exposed to corrosive vapors. There's more examples given in the annex, but if you have a harsh environment, you're going to want to test sooner rather than later. So that's where that 5-year or 10-year requirement comes in, and then the retest is every 5 years after that. Previous editions of NFPA 25 had some different years here. So in 2026 and 2023, the SFR, CMSA, and dry sprinklers are 20 years. I think it was the 2020 edition of NFPA 25 had 10 years for dry sprinklers, or no, might have been before that. Dry sprinklers were originally 10 years, and then they moved to 15, and now they're at 20 years. Essentially, when they were first introduced, there wasn't enough historical data to be able to, say you can wait 20, 30, 40 years. So they had the requirement shorter just to make sure that we're catching any, issues sooner rather than later. With the historical data that we've accumulated, that requirement has been pushed out. One big thing with the dry sprinklers too was that a lot of them were originally manufactured with the O-ring water seal designs. If now they have been remade without the O-ring there. So they're performing much better. That has contributed to the longer initial testing interval since the data backs that up. And again, now fast response sprinklers, same kind of thing. I think they're originally 20 years. Historical data has allowed them to be pushed out to 25 years. These requirements could change too, as more historical data is gathered. The requirement could be pushed out even further. And then all other types of sprinklers is going to be 50 years. So the subsequent testing is then after every 10 years. The subsequent testing is only relevant if the sprinklers pass. So if at 50 years you submit a sample for testing and one of them fails, you would then be replacing and the interval would start over. So you wouldn't have to do every 10 years after that. Once your sprinklers reach 75 years of age, you would be retesting every 5 years after that. And then if you have any sprinklers that are older than 1920, so if they were manufactured before 1920, those would just automatically need to be replaced. We're not allowed to have sprinklers manufactured before 1920 installed in the system. So this is the postcard is super helpful for verifying when your sprinklers need to be tested. Section 5.3 says you need to the laboratory. The annex gives a good example of an approved laboratory to complete the testing. So we'll move on to the next step here. Before you even take a sample of sprinklers and submit them to a laboratory, there is a visual inspection required. So the annex says you need to refer to section 52111, and any sprinkler that shows any signs of the following should be replaced. And so this is before you take any samples or define sample area, you need to replace sprinklers that show any signs of the following. So if you have leakage, which that could be, you got corrosion around the water seal indicating you have a slow leak and corrosion is starting to show up around the water seal. Here, I can annotate this for you guys. So yeah, you've got corrosion around the water seal. That would probably be an indication that you have some leakage happening. Corrosion detrimental to sprinkler performance. So it's not a specific, pretty vague, but if you have corrosion, it could be detrimental to performance. It's kind of up to the inspector to determine what is detrimental. You could also submit them to the laboratory for non-routine testing to see is this corrosion detrimental before you make a decision for that. Physical damage. So like this example here, this probably happened when it was removed from the system, but the frame's all bent. But if you have like deflector missing, or this is how it was installed in the system, you'd want to make sure that those are replaced before you're taking a representative sample. If you have loss of fluid in the glass bulb, so this one over here appears to have no fluid in the bulb, so the bulb was probably cracked and that fluid leaked out. It is possible to have discoloration on the bulb, so if it's in an area exposed to cold or in the sunlight, the fluid could become colorless. That's okay. The fluid is still present, but if the fluid has leaked out or is missing, that would be you need to replace those before taking your sample. And again, loading detrimental to sprinkler performance. So this here looks like a beehive of sorts on a sprinkler. This is probably going to impact the water spray pattern. So this could be detrimental to sprinkler performance. If you have loading around the release mechanism, that's going to insulate it, prevent it from activating as it should. So those would need to be replaced. You are allowed to clean sprinklers with pressurized air, as long as you're not touching the sprinkler. That is an option to remove some loading. But this, I think, was pretty hardened on there, so that's probably detrimental to performance. And then paint, other than that, of what's applied to the sprinkler, other than what the manufacturer applied, paint on the sprinkler that's detrimental to performance should also warrant replacement. Previous editions, I think the 2020 edition, if there was any paint on the sprinkler whatsoever, that would require a replacement. The 2023 edition modified that a bit, and it's just paint detrimental to performance. So that would be paint around the release mechanism, paint around the water seal. That is going to insulate the release mechanism, prevent it from operating as it should. The paint on the water seal is going to hold that water seal in place. Paint on the deflector could impact the water spray pattern. But if you have paint just on the frame, like a brush stroke, the ceiling painter accidentally got some paint on the frame of the sprinkler, that is not necessarily detrimental to performance. So that would not necessarily warrant replacement. So if you've looked at the standard, you've determined that your sprinklers need to be replaced, or not replaced, tested according to those intervals, then you have done your floor level inspection, and the next step is going to be sampling. So section 5312 says that a representative sample of 4 sprinklers or 1% of the number of sprinklers in the sample area. Whichever is greater should be tested. So if you have 400 or less sprinklers in your sample area, you would send in 4 sprinklers. Greater than that, you're going to use the 1%, because whichever is greater. So if you have 500 sprinklers, you would send in 5 sprinklers, 600 sprinklers, 6 sprinklers, so on and so forth. So that is where the number comes from for sampling. The next step is really defining the sample area. This is a really important step in the process. I think sometimes it gets overlooked until it's too late, but this should be a conversation that you as a contractor or you as a building owner are having with the contractor about defining the sample area. There's no definition provided in NFPA 25, and that's kind of done on purpose. It leaves it up to you, the building owner or the designated representative, to define. There's no requirements for how big the sample area needs to be or how small it can be, so you can really define it however you would like. You can define it by area or environment. Environment is probably a crucial aspect to consider, just because it's going to be sprinklers exposed to the same environment. I've also seen people define it by sprinkler type. That is an option, but however you define it, just make sure that you have that conversation with the building owner, because it can definitely impact the result. It impacts the number of sprinklers that are tested and also impacts the number of sprinklers that would need to be replaced. So this example here, this is actually in NFPA 25. Let's see, I don't know if here. This example, we have a warehouse with 5 systems, and each system has 300 sprinklers. And then we have an office area with 200 sprinklers. So one option would be to define the warehouse as one sample area, and then the office as the other. So in the warehouse, we have 1,500 total sprinklers, 5 systems at 300 sprinklers each, 1,500. So we would need to sample 1,500 is more than 400, so the 1% comes into play here. So you would need to sample 15 sprinklers from the warehouse, and then the office is the other area. There's only 200 sprinklers in the office, but we need a minimum of 4, so we would sample 4 sprinklers from the office for a total of 19 sprinklers tested. Option 2, you could define each system in the warehouse as a separate sample area. Then the office is another area. So then we would need 4 sprinklers from each system. So we would have 20 sprinklers from the warehouse and then another 4 from the office. So we have 24 sprinklers tested total for option 2. Option 3 would be to define the whole building, the warehouse and the office, as one sample area. So there's 1,700 sprinklers total. So you would test 17 sprinklers if you did option 3. So that's a conversation that should be had to figure out how to define the sample areas, determine how many sprinklers should be tested based on those sample areas. Again, you need a minimum of 4, but if you have more than 400, then you're going to follow the 1%. So whichever is greater. So that is the next step in the process. We determined our sprinklers need to be tested. We have determined that we've done our floor level inspection, eliminated any of those ones that have leakage, corrosion, paint, etc. And then we are defining our sample area in order to take our sample. So sampling. So we've defined our sample area. We want to make sure that we have a representative sample of sprinklers from each sample area. So each sprinkler type and manufacturer in your area should be represented in your sample set. The one caveat to that is the annex does say that sprinklers are the same type and manufacturer, but of a different orientation. So if everything's identical, but you just have some upright, some pendant, some sidewall, or some combination of those 3, those can be considered the same type. You would not necessarily need to sample one of each for your sample set. You could just sample one and the others would be included in that. When you're sampling, you should not be including any sprinklers that were replaced at prior testing intervals. So if 10 years ago you had to, pull 4 sprinklers to submit for testing, you want to make sure that your sampling does not include those 4 sprinklers. that you tested 10 years ago. You're resampling the sprinklers that were originally installed. So the other thing to note is sometimes we get asked, or one of the frequently asked questions is, can we sample sprinklers from the spare sprinkler box? That does not meet the NFPA 25 testing requirements. You want to make sure that your samples are installed in the environment that they're exposed to. The sprinklers in the box are going to be probably in pristine condition. They're more likely to pass, and they're not representative of the environment that you're sampling from. So we've defined our sample area. We've determined that we need to take samples that are representative of the system, and then we're going to submit them to a laboratory for testing. One option would be to submit to Dunn Fire Protection Lab. We are ISO 17025 accredited for sprinkler testing. We do offer results in 5 business days or less. We do offer rush testing if needed, so that's 24-hour turnaround. Our kits are free, so you can just request them through our website or giving us a call or sending us an email. You can request free sample kits. The standard kit, which is this one right here, is our standard sample kit. It holds 4 sprinklers. This kit is free, and it also includes shipping back to our laboratory if you're within the US. Our dry sprinkler kits are also free. We just charge a shipping and handling fee for those, and those do not include return shipping back to Dunn. We also manufacture and sell the DropMaster product, so that's the DropMaster DM25. This tool is really great for taking sprinklers more efficiently. You would drain your systems like usual. You would connect the DropMaster to the main drain. It puts the system under a vacuum, so when you're pulling your sprinklers from the water left in the drops is not coming out in buckets and tarps and all over the floor. It is actually getting pulled back up into the system and discharged through the DropMaster, so that you don't have to worry about using buckets and tarps to collect the water in the drop. So if you're interested in getting more information, our website, you can go to DunnUSA.com. The DropMaster tab is on the far right-hand side. To get more information, you can email the dropmasters.sales@nfpglobal.com for a quote, and they'll be happy to help you out with that. So we have determined our sprinklers need to be tested. We've done our floor level inspection. We've defined our sample area. We've taken our representative sample. We've ordered kits to submit for testing, and now our sprinklers are at the laboratory for the field service test. So section for Annex A 5311 tells us what we need to be testing. So the sprinklers that have passed the visual inspection, they're submitted to the laboratory for testing for sensitivity and functionality. So sensitivity is really referring to the release mechanism. Does the release mechanism activate in the appropriate amount of time? And how we measure that is through RTI, so the response time index, which is this fancy equation over here. It accounts for the temperature rating of the sprinkler, as well as the ambient temperature in the laboratory, the oven temperature, the oven velocity. It all accounts for that. It basically allows for the RTI to be used universally across different laboratories. So if you're just measuring the response time of the sprinkler, that may differ laboratory to laboratory, just because there could be slightly different ambient temperatures or slightly different oven velocities. And so the RTI allows for all that to be considered, and it makes it so that we have a value to compare across laboratories, which is how the standard defines this. So the thermal sensitivity should not exceed 350 for standard response sprinklers, 65 for quick response, and then 50 for ESFR sprinklers. And so the RTI is referencing the sensitivity release mechanism of the sprinkler. And then functionality is, does the water seal release and does the waterway clear when tested at 7 psi? So in our laboratory, this is a picture of our plunge oven over here. We use air for testing. There's no water involved. So the sprinkler would be attached to a test plate. It would be plunged into an oven at a specific oven velocity and temperature, and then plunged into the oven and connected to the 7 psi air pressure. And so the oven is going to obviously apply the heat and allow the sprinkler to activate. And then the functionality is, does the waterway clear after the release mechanism is activated? Does the waterway clear at 7 psi? So it is possible to pass sensitivity and fail functionality for a sprinkler, likely because you have corrosion around the water seal or something that's preventing the waterway from clearing fully. There's a common misconception that we're figuring out, just as the field service test is figuring out like at what temperature the sprinkler activates. That is more of an activation temperature test. And it would involve like ramping up the temperature of the oven to see at what point does the sprinkler activate. It's much more time consuming. That's why the standard allows for this RTI sensitivity and functionality testing. It's standardized and it does not take as much time. It obviously doesn't mimic real world scenarios, but it is a test for performance in a controlled environment. And this is how the sprinklers are tested when they're initially listed. So 7 psi may not sound like a lot. It is not a lot, but when they're initially listed, they're tested, I think it's 4 psi. So we're already allowing for some degradation with field samples. And so if they're failing at 7 psi, that means they've already degraded from when they were initially listed. So at that point, they should be replaced since they're showing signs of degradation. They could impact real world performance. Moving on to the next step here. This is a new thing in the 2026 edition of NFPA 25. They've added a section where if you have sprinklers that have been installed in dwelling units for 50 years, one of the following shall occur. You would need to replace all of the sprinklers with fast response sprinklers, or you can submit samples for testing, and the RTI should not exceed 65. So that is the RTI requirement for fast response sprinklers. So they're just essentially saying you either need to have fast response sprinklers in your dwelling unit, or your samples need to meet the requirements of fast response sprinklers. I'm not sure if that's possible, but that is allowed if you do have standard response sprinklers that would meet the RTI requirement of fast response. That would be acceptable. As far as what a dwelling unit is, essentially it's just anywhere where you could have living individuals, cooking, living, sanitary, and sleeping facilities. So dorms, apartments, condos, hotels, that kind of thing. Those would all be considered dwelling units. And so that's where we need to have fast response sprinklers in those areas. This is a new requirement in 2026. This is not in the previous edition. All right, so we have determined we needed to submit samples for testing. We've done our visual inspection to replace any sprinklers that show signs of any of those categories that we saw previously. We've defined our sample area. We've taken a representative sample. We've sent our samples to the laboratory, and now we have gotten our results back. So this is an example of our test report. So you have some administrative information up here at the top, who the report's for, the job name, the job address. Then we have some sample information. So most of this is obtained from looking at the sprinkler itself. So when was it manufactured, who's the manufacturer, the model, the response type. We also include the release mechanism and the water seal, and then whether or not it was a dry sprinkler. This location is going to be provided by the customer as well as the sample area. So that's provided by the customer, but included on our report. The meat of the report is this test result section. So I've blown it up over here. We have 3 different values reported, but the response times and the response time index are essentially the same result. We determine the response time, and then we calculate what the RTI would equal based on those factors I talked about. So the oven velocity, the temperature rating, the ambient temperature are all calculated, are all inputted and determined to figure out what the RTI would be. So if a sample passes response time, it's going to pass the response time index. So those values are correlated. But if another laboratory has a response time requirement, that might be slightly different because again, we're accounting for the laboratory conditions. the RTI is what's going to be that universal value that you can compare it to. So in this example, we had a response time of 121.1 seconds. The requirement, the maximum requirement is basically back calculating from the RTI requirement. So this is a standard response sprinkler. It's got to have an RTI less than 350. This one is close at 344, but it is passing. So response time and RTI are passing. So that's the sensitivity testing portion. And then this water seal release, that is the functionality. So this sprinkler activated on time, and then the water seal release at 7 psi. So you see full release there. The test results are passed across the board. It is possible to have, a response time and RTI that pass, but then the water seal it's kind of corroded into place, and you see like it did not release here, and it was failed functionality testing. For our reports, you'd get this report attached as a PDF. You'd have a page for each sprinkler sample that you submitted in the job. And then we also include pictures. So these pictures here are pictures of the sample submitted pre-testing. So this is before the testing is completed, the release mechanism is still intact. You can view the sample as it was received and the condition it was received. And we provide this so that if you do have a failure, so if the response time is too late, maybe you can look at the pictures and say, okay, well, there's some corrosion around the release mechanism or loading around the release mechanism. That's maybe why it activated too late, and that kind of thing. So we provide the sprinklers, the pictures before testing, and then we provide this post-testing picture as well. This is the picture of the sprinkler waterway. So that functionality testing is did the waterway clear at 7 psi? And so we say that the water seal was fully released, and then we provide a picture of the waterway of the sprinkler post-testing so you can kind of evaluate how clear it is. Maybe there could be debris still stuck in there. We're not evaluating like how clear the waterway is, but we are indicating did the water seal fully release, and then we provide that picture just for reference. So you would get your report as a PDF and these pictures for reference to kind of help explain the results that you're looking at. So let's talk about some failure statistics. Failures do happen. I just put these numbers together. 5.1% of sprinklers tested at Dunn to date have failed. So failure rate in general is about 5%. Why did they fail? Kind of broke it down a little bit further. So about 1% of sprinklers did not activate. So the release mechanism stayed intact. It did not activate in response to the heat in the oven. So that it, due to loading or corrosion, for whatever reason, they did not activate. And that's about 20% of the 5.1%. So 20% of the 5.1% failed sprinklers did not activate. 0.9% failed to activate on time. So in this case, the release mechanism did activate. It was just beyond the maximum time and RTI requirement. And that's about 17% of the 5.1%. And then 4% of sprinklers failed to release. So that means the water seal or the waterway was blocked. Something was preventing the waterway from releasing. That's about 78% of the 5.1%. If you're doing math, 20 plus 17 plus 78% is more than 100%. This bottom section here, if it failed to release, that could also mean that it failed to activate. So there is some overlap in those statistics. So that's why these numbers don't quite add up to 100. But yeah, did not activate means the release mechanism is still intact. Failed to activate, it just activated a little too late, and then failed to release. Likely the water seal is corroded in place on all these pictures up here. We have a water seal just still stuck in place here. This one's pretty bad. Looks maybe should have been replaced at the floor level visual inspection. And that's one thing I'll mention too. Sometimes we do get sprinklers that maybe should have been replaced at floor level inspection. We're not evaluating that. Those failures are included in these statistics. We don't separate those out. But these are just some examples of failed sprinklers. There are O-rings still out on the market, still out installed in buildings. 3.4% of the sprinklers we received in 2025 were O-ring water seal design sprinklers. And those have a super high failure rate, about 54% of those fail. So even if you submitted 4 sprinklers for testing, there's a high probability that, 2 or more of those are going to fail. They haven't been listed in over 20 years. They really should be replaced and recalled, but we do still see them. We don't identify them as recalled on the report, so it is one thing I'll mention. If you send us recalled sprinklers, we will test them as usual. They will pass, fail based on their sensitivity and functionality performance results. But for O-rings, we do indicate what the water seal design is. So if you get your report, you see water seal design is listed as O-ring water seal design. That is an indication that they should be replaced. They are recalled sprinklers. But in general, we don't explicitly define which sprinklers are recalled. And that's mostly just because there's no master list out there of recalled sprinklers. It'd be great if there was. It'd be great if we could easily identify them. But for our own liability, we don't want to miss one on accident, so we just choose not to define any recalled sprinklers. But for the O-rings, those are at least identified by the water seal right on the report, so you can easily identify that. And then they do have a really high failure rate. You'll see that more than likely in your results as well. All right, so what if you submitted your sprinklers to the laboratory and you get one that failed? Where you have one sprinkler within a sample set that failed, all the sprinklers within that sample area should be replaced. So we'll talk about that a little bit on the next slide with that example on the warehouse and the office a little bit we talked about earlier. We'll go through that example on the next slide. Here's some examples of sprinklers that have failed. Maybe they should have been replaced at the initial floor level inspection. That's outside of my area of expertise, but here's some examples we have received in the lab and they did fail. So this one on the left here, got some serious loading around the release mechanism. That obviously helps insulate the sprinkler. It prevented it from operating as it should. So this one failed. Sensitivity, I don't know if it might have activated too late, but it failed the sensitivity testing for sure, just because that loading was present. Again, you may be able to clean these in the field. That is an option as long as you're not touching the sprinkler. You can use air to help clean those off. But this one definitely failed the sensitivity testing due to that loading. This one here is pretty corroded. Did not activate, did not release. That corrosion it's a pretty color, but it is holding all those pieces securely in place. So it did not operate as it should. So this one failed both sensitivity and functionality. You got did not activate, did not release on the report there. This one here, again, corrosion around the water seal. This one activated as it should, so it passed the sensitivity testing for the response time and RTI, but it failed functionality. That water seal is glued into place and it's not going anywhere. So that's another example of a failure for the functionality testing. So looking at the example we talked about earlier, we had our warehouse with 5 systems, 300 sprinklers per system, and an office area with 200 sprinklers. For example, if we had one sprinkler from system 3 of the warehouse that failed, what does that look like for the 3 different options that we chose? So in option 1, remember we had the warehouse as one sample area and the office as the other. We only tested 19 sprinklers. In this example, since one sprinkler from the warehouse failed, we didn't separate each system. The warehouse is one area. All of the sprinklers in the warehouse should be replaced. So you'd be replacing 1,500 sprinklers in this example. So that's where defining the sample area is a really important step in this process. We may have saved a bit of money on the testing and only tested 19 sprinklers, but we are certainly paying for it in the cost of replacing those sprinklers because we are replacing 1,500 sprinklers. Option 2 here, we had each system in the warehouse as its own area and then the office. So in this example, we only need to replace system 3 in the warehouse since we separated them out. So we paid a little bit more to test 24 sprinklers, but we are saving on the replacement since we only need to replace system 3 in the warehouse. We just need to replace the 300 sprinklers in that area. Option 3 Remember, we had defined it as the whole building, warehouse and office, all one area. We wanted to save the most amount of money on the testing, so we only tested 17 sprinklers. It is possible that all those would pass, and then you save your money on the testing, and when they all pass, and they're good for another 10 years. But in this example, again, we're saying one of them failed, so we have to replace the whole building, which is 1,700 sprinklers. So that's just a conversation that you want to have beforehand. Defining that sample area is really important because it can greatly impact the end result if one of those sprinklers fails. All right, and then the last thing is just routine versus non-routine testing. So everything we've been talking about thus far is section 5.3 of NFPA 25. That's routine testing. So we have a set number of samples that need to be submitted. There's clear instructions on the intervals of when samples should be submitted for testing. That's all routine testing. There is non-routine testing. If you have another issue you're investigating or a certain area or problem that you have discovered and need to do some testing, that would be non-routine testing. You can also, if you have floating or corrosion that you're not sure is detrimental to performance, you can sample some of those and submit to a laboratory to make that determination. That would just be non-routine testing. So they're not subjected to the same requirements. It's not a specific number they need to submit. There's not, a specific sampling requirement that you need to be mindful of. It's just a non-routine test to kind of gather more information and investigate further. So that's just one thing I will mention. All right, so that is the meat of the webinar. I think we've had some questions roll in, so we can take a look at that. Jenny, do you have questions?
Yeah, we've got some questions coming in. Thank you guys for submitting those. I'm just going to try to scroll back up in my window here and get to kind of to the top of where they started. Let's see. Josh asked, do you need 4 of each type or just 4 heads, for example? They have QR heads due for testing, both uprights and pendants. Do you need 4 of each or 2 and 2?
Gotcha. So that's going to be kind of looking at this section here. If they're the same type and the same manufacturer, and they just differ in the upright pendant sidewall orientation aspect, you could consider those the same. So you would just need 1 in your sample set. If they're different manufacturers or different types of sprinklers, then you would just need to have one of each in your sample area. And to be a representative sample. Hopefully that answered your question. Let me know if not.
Just dry cover, dry pendant also. Not quite sure. You guys want to elaborate on that one?
I'm not sure what that means.
Yeah, I'm not sure on that one as well.
If I said dry, I was referring to a dry sprinkler. But yeah, feel free to elaborate. I'm not sure what that means.
Someone asked if the certificate credit is recognized by Cal Firefitters card. I have not heard of that. You can certainly submit our certificate of attendance I'll be sending to you via email to them and ask and let me know. And I would probably know that going forward. The only one I know for sure is that I've heard of people using it for knife set. But if there are any other ones that you guys need credits for, and that's something I can look into, feel free to shoot me an email. I'll put my contact information at the end of the chat, and it'll be in the follow-up email if we need to coordinate on anything like that. Are you collecting data as you do these tests that would assist AHJs in making data-driven decisions about how many samples must be taken from each environment?
Yeah, I mean, we maintain a record of the sprinklers that we tested, and we have various ways of querying that information. So we do have quite a bit of data on hand. If you have specific questions, you can feel free to email directly, and we can see if that's something we can share with you. But since we do a good amount of testing, we do have quite a bit of data to help the industry as needed. Okay,
thanks for that. Would sprinklers with different finishes be considered different types? An example, a white 155 QR pendant versus a brass 155 QR pendant. Usually painted sprinklers are more corrosive resistant.
I don't know for sure. There's not a specific definition of that in the standard, so I would consider those different. But that is my opinion and not necessarily a specific standard requirement. But I would consider those different. You just need one of each in your sample area.
When asked if they can download the presentation to share with their team, yes. I will send you a PDF of the slides that'll be attached to in my follow-up email. The certificate will come in one email. The other email will include the slide PDF, a survey, and a link to the recording. What if the existing sprinklers that are over 55 or 50 years old are 165-degree fusible link or lever style? Do you have to replace with a quick response 165 fusible link? Or can you use a quick response 155-degree glass bulb? Does that replacement have to be exact specs or just some of the same temperature classification?
That's getting into design a bit, and that is outside of my area of expertise. I'm not sure. I don't know if you're referring to the dwelling unit requirement. Those would need to be replaced with fast response sprinklers. But otherwise, you'd probably want to work with an engineer on the design aspect. I'm not sure exactly what you can replace with different response types. I'm not sure exactly outside of my area.
Do your statistics look at failure rates of bulb versus fusible link sprinklers?
The statistics I shared include everything. So this is all types of release mechanisms, all different ages of sprinklers, dry sprinklers, fast response, standard. This is a general statistic. In general, it's about 5%. If you're looking for specific information, see if that's something we could query for you, you just have to reach out to us directly. But yeah, this statistics that we shared is everything. So it's got glass bulb, solder, link, solder mechanism, all different types of water seals, it's everything.
If we are going off types, where pendants, uprights, and sidewalls can be considered the same type, and let's say the sidewalls are the only ones that fail, do we have to replace the entire sample set? If all three are present in the sample or just a sidewall?
Gotcha.
Very detailed.
Yeah, so it's going to depend on how you define your sample area. So if you've got, pendants, uprights, sidewalls included in your representative sample, and one of the sidewalls fails, you're going to look to how you define your sample area. So if you had all of those within the office area, and that's how you defined it, you would not just replace just the sidewalls, you would replace everything in the sample area. So all the sprinklers in the office would be replaced. If you had the upright pendants, sidewalls, and they're all the same type and manufacturer, so you just took one to represent all of them, same would apply. You would, if that one failed, you would replace all the sprinklers in that sample area, not just the type. You can define your sample area by type. I've seen that done before. Again, the standard is not specific, so you could choose to do that. But you would need 4 of each type if you're going to do that. I don't necessarily, again, that's a conversation to have with the building owner on what they would prefer. But if you did your sample areas by pendants, uprights, and sidewalls, you would then need at least 4 or 1%, whichever is greater, of each one. And then if one of those fails, you would just so if one of the sidewalls fails, you would just be replacing the sidewall. But that's because you've defined your sample area that way. If you're defining it by environment, you would replace everything in that environment. So for the office example, everything in the office would need to be replaced.
Thanks for that question and answer. That's a little bit of a 2-part. Can you only test after 50 years is reached? Or how long after 50 years does NFPA require for the sprinklers to be tested?
So if you just have standard sprinklers, no harsh environment, the initial test is not required until 50 years. This is a minimum requirement. You could certainly go above and beyond if you wanted to, but the initial requirement is not required until 50 years. And then it's every 10 years after that, but when it reaches 75 years of age, it's every 5 years. So if they pass, so if you did 50 years and they pass, you retest again at 60, and then they pass, you retest again at 70, but once they hit 75, you're doing that every 5 years after that.
Okay. Do pilot heads require same testing? Is that referring to outside of my?
Pilot heads. I'm not sure what that means, to be honest.
You want to elaborate on that? We can get back to you on that one, Sam. Follow up from the first question. Can you consider different residential K factors of 4.2K or 4.9 as the same type if the manufacturer is still the same from install?
Those might be different. My understanding of the annex definition is kind of everything is the same except for the orientation. So in that case, those would be different. And so those would probably be, you just want to have one of each in your sample area or in your sample set for 1%.
What about multi-unit housing apartment building? For instance, each building has independent riser. Does each building require any heads pulled as long as all the heads are the same?
You could have the whole complex one sample area if you wanted, I suppose. But then if any of them fail, then you have to replace all the sprinklers in all the buildings. So you could also do it by building. So if you just wanted to have each separate building be a sample area, then you just need 4 or 1% from each building. And that way, if one fails, you just have to replace one from each building. It's kind of up to you on how many does you and the building owner want to be testing. Just understanding what the consequences are if one of them fails.
When is the next webinar? The next webinar is going to be April 15th. Happens to be tax day. It's going to be on firefighting foam. Alyssa will be at a meeting at that time, so we're probably going to have Grant or someone else present that. So April 15th, and I'm going to try to make sure I got that set up ahead of my follow-up email to you guys so you can click on the register link and while that's fresh in your mind. Let's see. Do you have a list of heads that you've tested that have the O-ring seal?
There's some brochures out there. If you reach out directly, we might be able to send them to you. We use them for reference sometimes. So there are like brochures that have like a list of the model numbers that have the O-ring. Once you start to look at that, you can kind of identify how they look. And you might be able to more easily identify them out in the field. But they usually have a flat water seal. The Bellevues have a bit of you can see that there's the paper before the release mechanism. The O-rings are oftentimes flat. But there are some brochures out there. You might need to be able to Google them. O-ring, water seal, fire sprinklers or something like that do have a list of model numbers for sprinklers that were the O-ring water seal design.
Okay, I'm trying to find and see if we've got any other last minute questions coming in here. There's some talk about the pilot head, so thanks for kind of answering those and clarifying that if you guys want to take a look there. Referring to your sampling slide, what is defined as sprinkler type?
Sorry, can you say that again?
Referring to your sampling slide, yes. What is defined as sprinkler type?
know if there's a specific definition. The only other reference to same sample type is this in the annex, where if you have the same type in manufacturer, just different range. Same type is probably release mechanism type, manufacturer. I would imagine K factor would be included in there. They have different K factors. But the finish on the sprinkler could be considered a different type. It is a bit vague. My understanding is there's no specific definition. The only one is just, it just says same type in manufacturer. So I would assume everything's the same except for the orientation. So if something's different, those would be considered different types, is my understanding.
Along those lines, would different temperatures be different types?
Yes, I would consider those different types, different temperature readings.
Someone's asking us if we can share what our sprinkler testing pricing is.
You can reach out to the lab. Dunn.lab@nfpgold.com if you would like a quote for sprinkler testing.
That's about all I see coming in. If anybody has any last minute questions you want us to get through, feel free to still send them through. If there's any we've missed or I missed scrolling through, we'll look through them after and try to reach out to you individually. Someone's asking, it looks like another question on sampling. If you have a building with 6 different temperatures, then you would need 6 heads tested as opposed to 4.
Yes. So the number of required, the 4 or 1% is the minimum. If you need more than that to have a representative sample, then you would be submitting more than the 4 sprinklers. So yeah, correct. If you have 6 different temperatures, then you would need 6 different sprinklers to be represented in your sample instead of the 4.
And do you find that ESFR sprinklers have a high failure rate?
I think they do have a little bit higher failure rate. I don't know specifically what the failure rate is off the top of my head, but that's why they do have the shorter initial testing interval, 20 years instead of the 25 or 50 years. If you're looking for specific failure rates, just reach out and I should be able to get that for you. But off the top of my head, I think they do have a slightly higher failure rate, but nothing too crazy.
Can we order testing package kit to have the office on standby?
Yes, if you would like kits to have on hand, you can certainly request those. Again, if you're a current customer, you can request them to the website. You can call us or email the lab. If you're a new customer, you can certainly email us and call us and we can get you set up and get some kits out to you, no problem.
One of our standard sprinkler kits holds 4, as Alyssa told you about earlier in the presentation with the picture. Some people like to keep what's called a case on hand. That's 12, so up to 48 sprinklers there. If you do have a lot of jobs that you're doing relatively quickly, it's, more cost effective for us to ship you a case if you're going to go through those pretty quick. Go ahead and feel free to request that from us. And our customer service team is good about working with you on those. So.
Yeah, any other questions that we missed, feel free to reach out. You can email the lab, dunn.lab@nfpaglobal.com. I don't have my email on here, but it's Alyssa, ALYSSA.Dunn, DUNN, @nfpaglobal.com if you want to email me directly. You can also reply to the email that Jenny sends out with the recording link and the PDF slides if you have questions that we missed on the webinar.
Well, thank you for being here, everyone. Thank you for Alyssa for presenting us with the sprinkler information today. As she mentioned, we're going to be sending out that email here in the next couple days. We'll also have that certificate. If anyone was on the live, you'll be getting that. Watch the Dunn website, our LinkedIn or Facebook pages, and our monthly newsletter for more. Unless you have anything else, I'll say thank you for joining us today, and we'll see you next time.
Thank you.